Lesson 15, Graphing Solutions to Inequalities. Students graph solutions to inequality, taking care to interpret the solutions in the context of the problem. A local car dealership is trying to sell all the cars on its lot. Currently, there are 525 cars on the lot, and the general manager estimates that they will consistently sell 50 cars per week. Estimate how many weeks it will take for the number of cars on the lot to be less than 75. So I need the cars on the lot to be less than 75. So 75 is going to be my biggest number. So if 75 is my biggest number, it's going to look something like that. Write an inequality that can be used to find the number of full weeks W it will take for the number of cars to be less than 75. Since W is the number of full weeks or complete weeks, W equals 1 means at the end of week 1. So we have 525 cars. We sell, so take away 50 cars per week. That means to multiply. So I come up with my inequality of 525 minus 50 cars per week. We need to do this until it's less than 75. So now I've got to solve it. So I need to subtract 525 from each side. So then I get negative 50W is less than negative 450. Divide each side by the negative 50, which means because we're dividing by a negative, we're going to need to flip the inequality symbol. So when we divide, we get W is greater than 9. Notice I flipped it. So then we need to draw a number line. The only numbers I'm ever interested in are the number that we have and 0. So 9 and 0. Because this is W is greater than 9 or not equal to, our circle is going to be an open circle with a line pointing to the right. Explain why 50W was subtracted from 525 and why the less than inequality is used. 50W was subtracted. Subtraction was used because the cars are being sold. Therefore, the inventory was being reduced. The less than inequality was used because the question asked for the number of cars remaining to be less than 75. They didn't say 75 and equal to. In step 1 of the inequality was reversed. Why did this occur? The inequality in the problem reversed because both sides were divided by a negative number. Interpret the solution in the context of the problem. The number of cars in the lot will be less than 75 after 9 weeks. Verify our solution. So if I take my original inequality and I substitute 9 in, I wind up with 75 is less than 75. That's not true. So at the end of the 9th week, we're not going to have enough. So it's anything greater than 9. So if I do the same thing for 10, I wind up with 25 is less than 75, and that's true. The cost of renting a car is, is $25 per day plus a one-time fee of $75.50 for insurance. How many days can the car be rented if the total cost can be no more than $525? So no more than that means you can include that price. So we have $25 per day. That means to multiply. Plus, so we have 25x, so x is days, plus a one-time 750 or 75.50 for insurance. Solve and graph the inequality. So if I subtract 750 from both sides, I wind up with 25x is less than or equal to 449.50. So I need to take, that's the amount of days I can rent it. So if I divide each side by 25, I get x is less than or equal to 17.98 days. Well, we can't have 17.98 days, so we're going to have to round down to 17 days. Interpret the solution. To stay within budget, the car can be rented for 17 days or less. For each problem, write and solve and graph the inequality and interpret the solution within the context of the problem. Mrs. Smith decides to buy 3 sweaters and a pair of jeans. She has $120 in her wallet. If the price of the jeans is $35, what is the highest possible price of a sweater if each sweater is the same price? So we know that Mrs. Smith has $120. That's the most amount. So everything she buys needs to be less than that. So she brought jeans plus 3 sweaters. So we have 120 is greater than or equal to the $35 plus the 3 sweaters, 3S. If I subtract 35 from both sides, I wind up with $85 for the 3 sweaters. If I divide each side by 3, I wind up with a total of $28.33 at the most per sweater. So graph this. The cost of the sweater has to be less than the $28.33. So I draw a number line. The only 2 numbers I care about are 0 and the number I'm using, the $28.33. It's got to be a filled in circle because it's an or equals to here. And then context of the problem, the sweaters cannot be more than $28.33 to stay within her budget. The members of a select chorus agree to buy at least 250 tickets for an outside concert. They buy 20 fewer lawn tickets than they do balcony tickets. What is the least number of balcony tickets they bought? So we have the 250, which is the smallest number. So what we have over here needs to be bigger than that. We know we bought balcony tickets, and however many balcony tickets we bought 20 less for the lawn. So B minus 20 is for the lawn, and this is for the balcony. So then I need to start solving it, combining the like terms. So I have 250 is less than 2B minus 20. If I add 20 to both sides, I get 270 is less than 2B. Divide each side by 2. I get 135 is the least amount of balcony tickets they bought. So to graph that, it needs to be an open circle because it's a less than. And I want more, the B has to be more than 135. So my balcony tickets has to be more than 135. So it points to the right. And the chorus had to buy at least 135 balcony tickets.